Hello friends, this question is from the test series number 10. Subject name is network and topic name is sinusoidal steady state analysis. It's a linked data question. In a problem, we have one RLC circuit and there is a one voltage source of magnitude 6 volt is connected between resistor R and inductor L. Okay, so the 6 volt voltage source is connected between two nodes. Let's name this node as a V1 and V2. Right, and question says that the voltage across the capacitor V2 dash is okay. So they already named this node as a V2 and this voltage across this capacitor is V2. Okay, that we need to calculate. In the first problem we need to calculate the value of this V2, and the second question says that the complex power due to the dependent sources. So we need to calculate the complex power across this dependent source. So let's focus on the first part, in which we need to basically find the voltage across this capacitor, which we named as a V2. In the problem also it is named as a V2. So you can see that in the circuit diagram we have a one voltage source of 6 volt which has a positive polarity towards V2 and negative polarity towards V1. So, and there is no resistor in between V1 and V2. So basically this case is the case of a super node. So this voltage source is creating one super node between V1 and V2. We can apply the super node analysis here. So in the super node analysis we have one equation as a V2 minus V1 is equal to 6, right? Because of this voltage source, and now I'm going to consider these two nodes as a one node, okay? And I'm going to name and I'm going to apply the super node analysis here. So let's apply this theorem here. So by supernode analysis, in the nodal analysis we basically apply the KCL. So in this branch we have one dependent source 7V2 by 50. This is a 10 ohm resistor. Let's name this branch current as I dash. Let's name this across J2 we have a branch current as I double dash, and the capacitor we have a branch current as I triple dash. So let's apply the case supernode in the circuit. So if I want to apply the supernode here, so by KCL's theorem says that the incoming current is sum of the incoming current is equal to the sum of outgoing current. In the circuit we have only one incoming current, which is 7V2 by 50, and sum of the outgoing current is we have a 3 outgoing current, which is I dash plus I double dash plus I triple dash. So my current source is still 7V2 by 50, and my I dash is basically, it will be V1 by 10. My I double dash is it will be V2 by J2, and my I triple dashes will be V2 by minus J15. Right, now we already know that my V2 is basically V2 minus V1 is 6, so I can replace V1 as V2 minus 6 here. So if I can put it, the value of V1 here, it will be V2 by 50 upon V2 minus 6 by 10 plus V2 by J2 plus V2 by minus of J15. So we have one equation with one unknown, so it's a simple calculation. Now after simplification I can get my V2 as 13.84 with angle of 157.3 volt. So this is my answer for this question. My correct option is option B. So my V2 is 13.84 volt. Correct option is option B. So in the second part, question says that find out the complex power due to the dependent source. In the dependent source we know that the current is 7V2 by 50, and voltage across the current sources, voltage V1, which is basically V2 minus 6. We know that in the complex power is basically voltage into current 12. Okay, we take the complex conjugate of the current, okay, with one minus sign. So if I can write it down here, so my complex power is basically minus of minus 6 plus V2 into 7V2 by 50. So my power is, my is basically minus 37.57 minus J 4.473 is my power dissipation. So my correct option is option D. Option D is my correct option here. Option B is my correct option in the first part. Thank you.